Hi, my name is Caleb Padilla. This is Project 4 for Fundamentals of Aerodynamics with Dr. Ozbay. Um, I am going to be doing all of Part 2. I am working with Garen and Parneet Singh, who will work together to finish Part 1. Part 2 consists of fluid 2D flow simulation of airflow over a semicircular cylinder with a diameter of 1 meter. Free stream velocity is 30 meters per second, and density of air is given as 1.2 kilograms per meters cubed. And this is going to be viscous turbulent analysis. So we can go ahead into Workbench. This is my project from before. It will come into Fluid Flow Fluent and drag into here, and we'll go into geometry. So here in geometry, we'll click on the Z. This is 2D, open an XY plane, and now we'll start sketching. Click here, arc by center, and I'll come to the center of this plot. I'll just make our semicircle here. Now I can go into dimensions, click on diameter, change the diameter of this semicircle to 1, and now I'll just zoom in. And that's our semicircular cylinder. Now we will add lines. So from here, add a line, add another line here, and 2 vertical lines. I'm going to add another line here after I make these dimensions the same height. So I'll go to dimensions, general, go to this horizontal line. Let's just say we want to add 3 meters. So I'm going to put this one as 3 meters as well. 3 meters. And this one, let's say 2 meters. Or 1.5, just make it a little shorter. 5. 5 meters. Now I can draw a line connecting these 2 dots. Okay, now from here, go into modeling, drop down the XY plane, select my sketch, go into concepts, surface from sketches, and then apply, and then generate. And there's our geometry done. So I can go ahead, save this project. So from here, I can go back into Workbench, and now we'll open up our mesh. So now our mesh is open up here. From here, we want to right click on our mesh, and we're going to insert a method. Going to apply to our body. We're going to change our method to triangles, and we can just go ahead and generate. That's how we want our mesh to start off. From here, we want to right click on our mesh again. Now we're going to insert sizing. This is going to be the edge sizing. So we can go ahead and apply. We want the element size to be number of divisions. And we'll change this number of divisions to 75. Default growth rate. We want the curvature set to no. We want this behavior to be hard. No bias and no blend to neighbors. Here we can generate. Alright, this is what our mesh looks like now. Now from here, all we need to do is add inflation. With the faith, apply boundary, select the edge, apply. Want to change smooth transition to first layer thickness, and then we'll define our first layer height as 0.003. Our maximum layers we can set to 25. Keep a growth rate of 1.2. We'll go ahead and generate. Have over the cylinder. So now we're done with our mesh. You can come into mesh and change the element size, say 0.1. Go ahead and generate. Now it makes everything a little bit tighter. From here we can start naming, so I'll select this edge. This will be velocity inlet. This will be pressure outlet. We can name these symmetry. This will be our cylinder wall. Go ahead and save this just in case. Go back into Workbench. Make sure we update our mesh. Now it's updated, so we can go ahead into setup. Wait for that to open up. This pops up. We'll set this to double precision. It's going to be 4. 2D. Go ahead and start. And just wait for that to load up. So now we have our setup open. We can come down here into models, double click on this viscous here. We want it turbulent, so we can just go ahead and click K epsilon as our model. Click OK. And from here into our materials, go into our air, our properties, and our project was, our density was given as 1.2. So we'll just change this, close, and double click it just to make sure it did update, and it did. Now from here, we can go into boundary conditions. I guess we can double click here, double click on our velocity inlet. We'll open up and we can set our velocity magnitude to 30 meters per second, as was stated in our project description. Go ahead and apply, close, and just open it just to make sure saved, and it did. So from here, we can go into reference values, and we want to compute from our velocity inlet. Reference zone is surface body. So now we can go into initialization, hybrid, set our number of iterations to 25, apply. Now we can initialize. Our initialization is done, so we'll go into run calculation, change our number of iterations to 250, and then click calculate, and we'll let this run. Now our calculation is complete. Okay, so now after running calculation is complete, we can go ahead and start doing the individual parts. So we'll start with part A, just get the velocity contours with streamlines and pressure contour along the semicircular cylinder. So we'll start with the velocity contour with streamlines. Go back into workbench, Fluent. So we'll double click on contours, name this velocity contour. Velocity. Change this to velocity magnitude. We'll select the interior surface body. Go ahead, save and display. And there's our contour. Now to add the streamlines, we'll go into path lines. I'll just make this streamlines. Style line is good. Do 1,000 just to make sure it goes across the whole length. We can select our velocity inlet. I think that's all. Go ahead, save and display. Whoa. Okay. Click symmetry by accident to click velocity inlet. And there you go, better streamlines. Close here. Open up our contour again. And then in our path lines, open streamline, add to, and add to the contour. And there's our velocity contour with our streamlines. Now to get our pressure contours, go to contours again. This will be static pressure, interior surface body, save and display. There's our static pressure contour. Do the same thing for dynamic and total. Dynamic pressure. There's a contour for dynamic pressure. And then lastly, total pressure. And there's our contour for total pressure. Okay, let me close out of here. Now we can move on to part B, which is plotting the pressure coefficient and the velocity distribution over the surface of the semicircular cylinder. Okay, go back into Fluent. Go down to XY plot. We'll name this our pressure coefficient. Change this to pressure coefficient here over our interior surface body. Go ahead and save our plot. Well, okay, I did something wrong. Sorry, should be cylinder wall. And there's our pressure coefficient. Now we'll do the same thing for our velocity distribution. Velocity distribution. Velocity here, our x velocity of the cylinder wall, and then we should get our plot to be 0, which we do. It's constant 0. This is because of the no slip condition, so the velocity along the cylinder wall will be 0. Alright, now lastly we can go here and do part C. So we get the drag and lift coefficient for the semicircular cylinder from Fluent. So go back into Fluent. Where is it? Go into report definitions. Select new force report. I'll click drag. We want our drag coefficient over the cylinder wall. We click compute. And right here we have drag coefficient of 0.30070977. We're going to do the same for the lift coefficient. So come into force report, lift coefficient selected, cylinder wall, click compute. And there we have our lift coefficient as 1.371975. Well, that concludes part 2 for project 4. Again, my partners Garen and Parneet Singh will be working together to complete part 1. Thank you for watching.